Uh, let's see some laws related to union and intersection of three sets A, B, C. We have already seen some laws related to two sets like A intersection B, B intersection A, union, uh, commutative law, and so on. Okay. Now it is related to three sets, guys. Okay. When related to two sets, we have already done. So let's see the laws related to three sets A, B, and C. The first is associative law. It is like this: like if A union B union C, if simply without any bracket, also if it is written A union B union C, I haven't placed any bracket here. So it means this: you can associate any two with a bracket. Okay, like A union B, you calculate first and then you take union with C. Okay, or else what you can do, you can take union of B and C, B union C, and then you take union with A. So you can easily prove by using Venn diagram of three sets. Okay, that this holds. Okay, we will see the proof of using Venn diagram of the property that we are going to do next after associative. Okay, so A union B union C, in short, without bracket, is this: you can associate any two. Okay, like this. All are same. Okay, so this is the first law, which is associative law: A union B union C. Okay, now after this, uh, it is related to A intersection B intersection C as well. Now here also associative law, we can associate A and B. Okay, A and B intersection. First we take intersection of A and B, and then whatever we get, we will take intersection with C. Okay, now we can also do it like this: we can associate B and C, like we will find the intersection of B and C first, and then we will take intersection with A. That also is correct. Okay, so in a similar way, as I said, it can be proved using Venn diagram, and this is the associative law. Okay, so this is quite simple. So remembering this won't be a big issue. Now coming on to the next, which is something which is quite used in questions in mains, and so it is important. That law is what we call, guys, distributive laws. So in the first, it involves both here. It involves union as well as intersection. As you can see here, union is also there, intersection is also present here. Now A union bracket B intersection C is what the distributive law says, that we can distribute to A union to B and C. So A union, distributing it A to A union, A to B as A union B, and distribute to A to C, which is A union C, and in between some sign will come. What will come here, guys? Hmm? So, guys, yes, it would be intersection. So, this is distributive law. A union B unions B intersection C bracket is A union B bracket intersection A union C bracket. This is first law. So, in a similar way, if I ask you, if I replace union and intersection, it will give the second distributive law, which is this, guys: A intersection B union C. So you might have understood by now that it is distributing A intersection in B as well as in C gives us A intersection B and A intersection C. This is the distribution of intersection in B union C. Now in between the sign will come what? Yes, so in between the sign will come whatever is there between B and C, that sign will come here. As you can see here also, whatever was between B and C, that sign came here. Okay, So this is another version of distributive law. These are the two distributive laws. A intersection bracket B union C is A intersection B union of A intersection C. Okay, that we can distribute. Now let's see the proof of this. So I will draw first. I will first draw A intersection B union C. So B union C I have drawn. So this is B union C, guys. Now if I take intersection with A, now if I take B union C intersection with A in the given figure, it will become what, guys? This A is this circle, so this area would be what? This area would be this A intersection B union C. Okay, this is the area. So this was what? This is LHS we did. Okay, so LHS we are doing. So LHS part is shaded in this red region. Now moving on to the right hand side, so we will separately calculate A intersection B and A intersection C, and then we will take their union and see if it comes out to be equal to LHS. So A intersection B is plotted here like this. A intersection B is given by this shaded region. Similarly, A intersection C is depicted by this shaded region. Now if I ask you to take their union, guys, if I ask you to take the union of these two, it will give you what? So it will create this extra region. This region which is not here will come, and this is the common region of A intersection B intersection C, which is present in both. And here this region, it is not here, but it is here. So this will also come, this will also come. So in short, from these two we can say that from here and from here, if you see, it is nothing but this only. Okay, so that way we can say that it is same, it is proved. Okay, now let's see some example. Let's simplify B union A dash union B dash whole dash. How we will simplify this, guys? Simplify means convert it in lowest terms in A or B or both. A and or B or both. So how we will approach this, guys? What is the hint to this problem? So if you think, if you must have seen this before in questions with this kind of thing where complements are involved, we use what? We use De Morgan's law, guys. We use De Morgan's law. Okay, so De Morgan's law, A dash union B dash is A union B. This is the De Morgan's law. Okay, so that way we will do, guys. So the same way in the solution, A dash union B dash dash De Morgan's law, A intersection B it came. Guys, sorry, this should be intersection. This shouldn't be union, De Morgan's law. So this is intersection. So here also it is intersection only. A intersection B. Now we will use what? From here to here, we will distribute union in A intersection B. So we will use distributive law. So it becomes BUA, and then it is BUB. Okay, intersection will come in between because this sign is in connecting A and B. Now B union B, we know that it is B only. B union A is B union A. Now B union A intersection B is what, guys? Which is the answer? What should be the answer to B union A intersection B? So guys, B union A, we know that B union A, B is a subset of B union A. So if you take intersection of B union A with B, since B is a subset of B union A, it will give B only. So the answer is B, guys. Okay, answer is B. Now let's try this single correct objective. X intersection x u y whole dash is equal to what? A option x, B option y, C phi, D none. So how we will approach this, guys? So a hint again, as you can see here, this x u y whole dash is there, so it hints us towards De Morgan's law here as well. Okay, and then we will use the property what we did now. Okay, so and what about the second method? The second method of approaching this is what? So guys, it is nothing but the same. We can use, since two sets are involved, instead, if you are not aware or if we do not remember the property, but we are aware that we know that it is proved by Venn diagram. So using Venn diagram also we can solve this. Okay, so we will solve it by the first method. Okay, Venn diagram you can do on your own. So x union x u y dash, this question we will write, and using De Morgan's law, this becomes x dash intersection y dash. Okay, now from here to here, which property we will use? We will use associative property. Associative property, because here intersection and intersection only are there. So we will associate x intersection x dash in the bracket, and we will separate it from y dash. Okay, so x intersection x dash, we know that they are complement of each other. They are by nature, they are disjoint sets, so their intersection is phi. Now we know that phi intersection with any of the sets is phi only. So answer is phi, which is which option, guys? Option C. Okay. Now guys, let's try this sum, which is A intersection B dash whole complement union B intersection C dash is equal to what? We have to single one out of these four options: A dash union B union C, A dash union B, A dash intersection C dash, A dash intersection B. So how we will proceed with this, guys? What should be our approach? What should be the hint to this problem, guys? So as you can see here, when the complement is involved here, so we will start with again De Morgan's law, and then we, since union intersections are involved of three sets, we will obviously go for associative or distributive, whichever is applicable while solving it. So approach is same. You will use De Morgan's first, and then we will use the property related to the three sets of union intersection. So this question, using De Morgan's law, in the next step it becomes what? So here which sign will come, guys? This question mark would be replaced by what if we use De Morgan's law? Yes, since it is intersection here, it should be union here. And here A is replaced by A dash, and B dash dash, the complement of B dash is B only. So using De Morgan's law, this is this. Okay. Now this is same. Okay. Now in the next step, let's say this is D. Okay. Let's say this set is D. So D union B intersection C dash, we must recall which result. It reminds us of the distributive formula. Okay, so distributive property. So D is distributed over union in B intersection C. So it will be D union B intersection D union C dash. Okay. Now D union B, D is what? A dash union B. So D we will resubstitute as A dash union B here as well as here. Okay. I will resubstitute it here. I can place another bracket also, and even if I don't place it, it is same. So as you can see here, if I remove this bracket which I placed here and I associate using associative property, okay, instead of A dash union B, if I simply write I associate B union B instead of A dash and B, B union B will give us B only. Okay, here A union B is as it is, C dash is as it is, no change in the second expression. Okay, now this is equal to A union B intersection A union B union C dash is A dash union B. Now why, guys? So it is because of the reason that A dash union B, we are taking union with C, and this is also A dash union B. So A dash union B is basically a subset of A dash union B union C. Since it's a subset, their intersection will give you A dash union B only, which is which option, guys? B option, guys. Okay.
Next is the difference of two sets, guys. Difference of two sets A and B. So if two sets are given, this is set A, this is set B. Okay, difference of two sets. The first thing, if I define A minus B, this is equal to what, guys? So A minus B is A only, from which we have to exclude what? We have to exclude the intersection with B, or whatever it shares common elements with B that needs to be excluded. This we have to, this part we have to exclude. Okay, so what this region means, guys? So this region A minus B is, as you can see here, this can be defined as A minus A intersection B. As you can see here, A, this is A intersection B, and this A we are excluding A intersection B, so this area we are getting, which is A minus B. Okay, so A intersection B we have excluded, so A minus A intersection B. One more way to define A minus B is what, guys? Any idea? So A minus B is also defined as A intersection B dash. Now if you using the way we did in proving the De Morgan's law, in the same way, if you calculate this A minus A intersection B dash, you will see, you will get the same area of A minus B. So it is what, guys? It is A minus B is same as A intersection B dash, or we can also write it as subtracting A from A intersection B dash. So this is the meaning of A minus B, which is A minus A intersection B or A intersection B dash, guys. Okay, so similar way, in a similar way, if we define what is B minus A, so B minus A would be what, guys? It is B minus A intersection B, and it is B intersection of A dash, guys. So area should be what, guys? Yes, this is the area B minus A, guys. This is B minus A. B minus A. So V minus A is defined like this, excluding B elements, excluding A intersection B elements from B, or taking intersection of B and A dash. Okay. Let's take an example, guys. Let's say the universal set is defined as 10, 11, 12 till 26. Set A is defined as 11, 12, 23, 24. 4 elements it has. B is defined as 19, 11, 24, 25, 26. So now the question is, find A minus B. A part. Second, they are asking, is B minus A equals to A? Okay, this is the question mark here. And the third part, they are asking to find B minus A dash. In the fourth, A dash dash. Okay, so let's start. If you see the fourth part, this is a property. Okay, A, if you take complement and again complement, A complement of complement is A only, so the fourth part will give you answer A. So it is A only, guys. Okay, so this is the answer of fourth part which we did. Okay, first, this is A, guys. Now let's try to find out A minus B. Okay, A part. So A minus B, as you can see here, the common elements shared with A and B. A minus B is what? A minus A intersection B. So A intersection B elements, if you see, this is 12. 12 is not common here. Intersection B. So 11 is common here, guys. 11 is common here. 24 is common here. 12, 23. So only two elements are common. So from A, if we exclude this and this, so we will get A minus B, which is what? 12, 23, guys. 12 comma 23. Okay, now B minus A. Now in second part, can we do it like this? B minus A, multiplying it by minus sign, minus, this kind of thing that we do in algebra. Can we do this? Is it correct or wrong? So let's see, guys. B minus A. So B set was what? B set so B and A is this. Now if we calculate B minus A, so the common element, which is 11 and 24, that we will exclude from B. So B minus A is 19, 25, 26, and B minus A, if you see, so B minus A, so the common element of B minus A and B are 19, right, 25, 26. So B minus of B minus A would be nothing but 11, 24, guys. Okay, B minus A, so we will exclude 19, 25, 26 from B. So we would be left with what? You would be left with 11 and 24. So B minus A is clearly not equal to A. Okay, which is where A is this, so it is not equal to A. So this, the second part, B minus A, is it equal to A? The answer is, guys, what? Answer is no, it's not equal, guys. Now in the third part, we have to find what? B minus A whole complement. So B minus A, we calculated, it came out to be, B minus A came out to be like this, 19, 25, 26, right? And universal set, it was what? It was from 10 to 26. Okay, universal set was from 10, 11 to 26. So B minus A whole complement means what? B minus A dash means we have to select numbers from U and subtract B minus A. Okay, so from this, if you subtract U, which is 10, 11, 12 till 26, okay, if you subtract B minus A, which is 19, 25, 26, what you will get is 10, 11, 12 till 18. After 18, 19 won't come, 20, 21 till 24. So this is B minus A dash, guys. Okay, let's see some properties. Now what if A minus B is equal to A? In that case, A intersection B is equal to what? So A minus B is A. It means, obviously, we can say that if A minus B is A, so this is nothing, this is not there. It means this case is wrong. It should be like this. Okay, A and B. So that A minus B, since there is no common region, it is A only. So in that case, since there is no intersection, A intersection B is phi. Okay, so this is the case when A and B are disjoint. In that case only, A minus B is equal to A. So A intersection B is what? It is phi. Now what is A minus B union B, guys? Any idea? A minus B union B. So A minus B is this. This is A minus B. So A minus B is this. Okay, this is A minus B, and this is B. Okay, which is this. A minus B, if you take union of these two, what we will get would be something like this. So which is what? Which is, we know that it is A union B, guys. So A minus B union B is what, guys? It is A union B. Okay, now what about A minus B union B minus A in terms of A union B and A intersection B, guys? So A minus B union B minus A. So this A, this is B, A, this is B, this is A minus B, this area is B minus A. Okay, A minus B, B minus A. So if you are taking union of these two, as you can see, it is A union B only, but we have to exclude this area. So we have to exclude this area, which is what, guys? A intersection B. So guys, A minus B, A union B minus A in terms of A union B and A intersection B is A union B minus A intersection B. Okay.
So guys, let's see some properties related to difference of sets. We have seen some properties related to difference like A minus B. There were only two sets only, but this time we will see the properties related to difference of sets for not only for two, but there are three sets involved. Okay, so there are three sets A, B, C involved, and we'll see the properties related to them where difference and union intersections are involved. So the first is A minus B union C is equal to A minus B, A minus C. So now if suppose if I ask you what will come in this, question mark would be replaced by what? What you will say, guys? Hmm? So guys, we will establish that this would be replaced by intersection, guys. So A minus B union C, if we subtract A minus B union C, we will get the intersection of A minus B and A minus C, guys. Similarly, the second property A minus B intersection C. A minus B intersection C is what, guys? So here also uh, there would be some operator union or intersection which connects A minus B and A minus C. What it should be in this case, guys? So yes, guys, from the previous property we can easily guess that this now has to be union. So A minus B intersection C is the union of A minus B and A minus C, guys. Okay, now the third property A union B minus C, guys. So it is A minus B, B minus C. So what will come here, guys? So guys, this would be replaced by what? So guys, here A union B minus C is A minus C, B minus C. Here also U will come, guys. And A intersection B minus C is A minus C intersection B minus C, guys. So these properties are related to the three sets. Let's try to prove first property, which is A minus of B union C is A minus B intersection A minus C. Now we know that A minus B is defined as the intersection of A with B dash. So we can replace here B by B union C. If B is replaced by a set B union C, here also B is replaced by B union C. Okay. So using this result, now B union C dash will become this by what? It becomes B dash intersection C dash. It becomes B dash intersection C dash using what, guys? Yes, it is using De Morgan's law. Okay. Now here, let's say this is the end of LHS. Okay. So this is LHS. Okay. Now we will see RHS. Okay. So this is RHS now, which was A minus B intersection A minus C. So A minus B, as usual, using the formula, we can write it as A intersection B dash, and A minus C we can write as A intersection C dash. Okay, now from here to the next step, A intersection B dash intersection A intersection B dash, if we consider it as a separate set, let's say it is D, this is A, this is C. So if you can see it as a three sets, okay, 1, 2 and 3, which are connected by intersection. So using associative property, we can associate A intersection B dash with A. These two we can associate intersection C dash as it is, guys. Now we know that intersection of A and A is A only, okay, and B dash is as it is. So A intersection B dash intersection C dash we got from the RHS. Oh, and now if you use again associative property in the next step, if you write it like this, A intersection B dash intersection C dash using associative property, you will see this is nothing but what we got is nothing but same as what we got here in the LHS. So that way we can establish, that way we can prove. Another way is obviously we can use Venn diagram method. Okay, now let's take one question which is multiple correct. We have to mark the correct options, and the 4 options given are these. The first option is for all sets A and B, A minus B union A intersection B is equal to A. For all sets A, B and C, if A is a subset of B, then A intersection C is a subset of B union C. Third option is for all sets A, B, C, if A is a subset of B, then A union C is a subset of B union C. And D, for all sets A and B, A, B, C, A minus of B minus C bracket is equal to A minus B bracket minus C. We have to find which one of these options are correct. So the question arises, what should be our approach? So since nothing is given in the question, we are only left with the verification of the options. So we need to check each options. Check each options means check and solve each options whether for its correctness or not. So we will check each options. So we will check option number A first. A minus B union A intersection B is equal to A. So A minus B is, we know it is this. This is A minus B. And A intersection B is, we know it is this. So if you take the union of these two, we will get A only. As you can clearly see that this entire area is nothing but A, which is self-explanatory. So A option is correct. Okay. Now, if A is a subset of B, second option, then A intersection C is a subset of B intersection C. Okay, A is a subset of B, then we have to check whether A intersection C is subset of B intersection C or not. So for that, I will draw, since A is a subset of B, it is given, I will make two circles, one inside the other. The smaller one, since it has to be A, and the outside one it has to be B, then only A subset of B will be satisfied. And then in a generalized way, I will draw a set C such that it has some intersection with both A and B sets. As you can see, C is intersecting the circle of A also and the circle of B also here. Now, what is given in the question? Now, A intersection C, if you see, A intersection C, if you draw, it is this. This is A intersection C. Okay. This is A intersection C. Now, B intersection C, if you draw, it would be what, guys? B intersection C, if I draw like this, this is B intersection C, guys. So this is B intersection C. As you can clearly see that A intersection C comes under the area of B intersection C. So we can say that option B is also correct, guys. Okay. Now similarly, in the similar way, this C option is quite similar to the one we did in option B. Now in this we need to check if A is a subset of B, then we have to check whether A union C is a subset of B union C or not. So similarly, since A is a subset of B, we have I have drawn set A which is inside set B circle or ellipse. Okay. Now set C I have drawn in a generalized way which is intersecting both A and B like this. Now what I will find A union C, guys. So I will find A union C is what, guys? It is this is A and C. So this A union C is this. Okay, like this. So in this green, this is A union C. Now B union C, if I draw using red, it would be this entire area which is like this, guys. So as you can see here, this red area is completely encompassing, including, containing the area of A union C. So B union C is this marked by red, which is containing the area marked by green. So this C option is what, guys? Yes, it is true, guys. And let's see D options. Let's check D option now. A minus B minus C, guys. Now LHS, we will find LHS A minus B minus C. We have to check whether it is A minus B bracket minus C or not. So LHS, if we solve B minus C, A minus B minus C can be written as A intersection B intersection B minus C dash. Now B minus C again, from the definition of difference of two sets, can be written as B intersection C dash. Now B intersection C dash can be written as using De Morgan's law. It can be written as B dash intersection, using De Morgan's law, B intersection C dash whole dash can be written as B dash intersection C, while A remains the same. Now in the we will say that, let's say this is first, okay, A intersection B dash intersection C, okay, which is LHS. Now RHS is A minus B minus C. So again, A minus B from the definition can be written as A minus B dash minus C as it is. Now A minus B dash minus C from the definition can be written as A minus B dash minus C dash intersection C dash. Okay, now if you compare this and this, LHS and RHS, this is clearly RHS, which is this, and LHS, which is A intersection B dash intersection C, which is clearly not equal. Okay, so we can say that D option isn't correct. So out of the 4 given options, guys, the correct ones are A, B and C. Okay, so that's how we will do this.